All right. Good morning. Good evening, everything, everyone. Kadir, I think you had some question.
No, I'm good. I'm good. I was just responding to you. I was not able to unmute myself. I'm good now.
Good, good. Okay, no
Yeah.
problem. All right. So
Yeah,
we
sure.
can.
Malik same here. I got unable to minute. Good morning. Thank you.
Good morning. All right. So I have few topics to cover today. Uh, the some technical topics. What I wanted to cover is some networking in RAC and the RAC architecture and RAC installation and then RAC administration. At a high level, not in depth, I'm gonna go. I'll just brief it at high level. All this four technical concept in today's session. But before that, I can quickly recap what we covered in yesterday's session. Yesterday, we started with the introduction about me. I'll be delivering this entire RAC course, and I just briefed in few liners about my overall experience and areas of expertise. And we went ahead with the course curriculum. Uh, the link is here. I think if you want to revisit this course content, you can take a look on this course curriculum here. I'm going to ping this link again in this chat window here. Right. So we went ahead with this course curriculum understanding yesterday, uh, and I opened here. So it has uh, so many topics. We went ahead with each and every topic and what will be covered inside that. At the high level overview, I mentioned this course content here, but there are much more to cover inside each topic. Once we continue with our regular classes, you'll understand what all those topics, what will be covered. But at the high level overview brief, I just mentioned the high level points, the bullet points here for the RAC curriculum. And then we went ahead with a discussion yesterday about the course duration, timing, and fee structure. Again, this is the weekday batch, Thursday and Friday in IST time zone. Uh, the timing will be 8:30 a.m. IST to 11:30 a.m. IST, 3 hours on Thursday and 3 hours on Friday. In EST time zone, it will be 11 p.m. EST to 2 a.m. EST. That will be late night for in EST time zone. 3 hours for each of those days. So in 7 weeks, we should be able to complete this course. And this is a paid training and course fees will be 15K INR, Indian rupees, or 185 US dollar. Will be conducted over a live Zoom session. We'll be covering this 19C version. So the actual class will be starting on 20th November. And yesterday and today were two demo sessions. Right, and then we briefed about the Google Drive link access. What are the importance and what it will be containing. And again, I got a couple of pings yesterday. Is this Google Drive link and WhatsApp will be lifetime accessible? Yes, this Google Drive link is lifetime accessible, and WhatsApp group will be available forever until unless you be actively participating and asking question and queries will be kept active. Otherwise, we'll remove that or decommission that WhatsApp group. Right, and then post that we got a couple of pings for the payment, and few students got registered. Hope I have added all those registered students into WhatsApp group. So again, I'm going to ping this WhatsApp number or cell number in the chat here. You can take a note, and if you are interested, you can feel free to ping me. I can guide you to further payment process. Post that we discussed about some important aspect on the minimum criteria or minimum prerequisites, what is needed for this RAC course. Basics of Linux, Windows, SQLs are must, and the basic or prior knowledge of database is must, and the hardware minimum 20 GB RAM and 100 or 150 SSD hard disk is must because we'll be setting up of lab on your own laptop or desktop. Right, that's the prerequisites what we discussed yesterday, and then followed by certifications as a junior DBA. 19C OCP certificate is must. If you have this certification, your resume will be having a highest weightage and you should be able to get a lot of interview calls. And for the senior DBA experienced person with a 4+ of years of experience, you should be able to crack this RAC certificate. And even after completion of this course, you should be able to crack this RAC certificate. And this is the must. These two are like bare minimum certificate a DBA has to complete. And followed by, if you're interested, you can go with a specialization certificate on your areas of interest. Exadata, EBS, OBI, Golden Gate, OEM, Supercluster, Exalogic, and cloud technologies or whatever. And post that, some interesting questions or conversations where regularly we used to discuss in our friend circles or in our every classes what we start, or regular questions from our students. Is the cloud technologies making an impact? Is ChatGPT, Gen AI, Agentic AI making an impact? Is the DevOps learning is must thing for DBA? And which cloud technologies are good for DBA? And I do have some career gap after my college graduation, or I do have some career gap after my, few years of experience. How to deal with that? Again, we went ahead with the in brief discussion on all these major discussion points in our yesterday session. I'm not gonna recover that once again here. So and then we talked about some migration stuffs, and then followed by we started with some technical discussion. What Oracle is special? Why Oracle is so important than the other databases? And in Oracle, standalone versus RAC, and which is the preferred one for the enterprise customer? And then why RAC? What are the RAC advantages? And what's the best practices? And then what are the type of databases, standalone and RAC? And in standalone with ASM, standalone without ASM. And then Oracle highly recommends to run your database on ASM. And what is this ASM, automatic storage management, and what are the advantages? And what is this RAC database and RAC database plus RAC one node database? And what's the difference? Why RAC one node database came into picture? Right, those all concept we talked about that technical stuff yesterday, along with this all the other course details. Now I'm gonna continue further on those technical discussion. We'll talk furthermore into some architecture parts, networking and file system. So that's the plan for today. I'll take a pause here if anyone has any questions, not only related to this course curriculum or anything in general, what you feel about track or some common discussion you used to have it in your friend circle. Feel free to unmute yourself and ask, or you can post it in the chat window here. I'll take those questions. All right. If no questions further, then I will start with some concept, whatever planned for today. Networking, architecture, installation, and administration part. So I'll take it as a no questions. Then let's continue. So what we talked here are types of databases in as part of our DBA course. There's other course what we conduct DBA course. So you should be attending this DBA course before attending this RAC course. In that DBA course, we cover standalone databases, standalone with ASM, standalone without ASM, where database is running under OS file system or database running under ASM file system. A DB and test DB, what we cover in our database course. And in this course, what we cover is the RAC database, DevDB1 and DevDB2. It's a two-node RAC database, or RAC one-node database, DevDB_1 or DevDB_2. And then we talked about yesterday why RAC and what are the advantages, and standalone versus RAC, why RAC is more powerful than the standalone. The three important points what we discussed was HA, high availability, and load balancing, and a failover. These are the three main concepts what we discussed yesterday at high level. And what exactly mean of high availability? In RAC, we have multiple cluster nodes. Multiple RAC cluster node will help in end user connection. End user wanted to connect to database to do some query or transaction. In case of any one of the node is down, other node will take over that connection, take that incoming connection, and then support or sustain or allow that end user to connect to database and perform his query execution. So that is your high availability. In case of standalone, it's only one server. If that server goes down or crashes, and end user connections will not be connected, and end user has to wait until that server to back online and then allow user to connect. How this high availability will be achieved using this multiple node? Who can help in this one? There's something called scan. So scan is a single client access name. Scan stand for single client access name. The scan is comes into picture. Scan will handle this high availability. It will take that end user connections, and scan will be having multiple IPs. The default is 3 IPs, and with the help of scan, we'll be able to achieve this high availability and load balancing. The scan will help into client side connection high availability, and then server side connection load balancing. Again, in our actual regular course, we'll discuss more on that, what exactly the scan, how scan works, and what is the scan architecture, how the scan is able to have this high availability on the client connection side and load balancing on the server side. So we'll go more details, but that is with the help of these built-in concept or structure, we should be able to achieve this high availability in RAC. In case of load balancing, common questions like who is, again, I explained load balancing, the load or the end user connections will be evenly distributed on all the RAC cluster nodes. So I explained with this diagram in yesterday's session, high availability, load balancing, and failover. Who is responsible for load balancing? And that will be your, again, scan is responsible for the load balancing. And again, what is scan? The scan I just mentioned, single client naming convention. For the end user point of view, he no need to worry about how many rack nodes. It's a 2 node, 3 node, 4 node, right? So it's a single naming convention, single client access naming convention, where irrespective of your rack is made up of 2 node, 4 node, 8 node, the end user will not be aware. The application user or the client will not be aware of that. He will be given with one standard scan name and he will connect using that one. The scan is responsible for making this load balancing properly in rack setup. And then what is the scan? That architecture has separate concept. We'll explain in our regular classes. And I just mentioned scan will be having a default 3 IPs, and there's the 3 VIPs. People will call it as the 3 IPs or the 3 VIPs. Both are here. Scan is always made up of VIPs. So in a simple terminology, people will call it as a 3 IPs for scan. But it's actually not IPs, it's a scan VIPs. So why 3 IPs for the scan? And then how scan is able to perform load balancing? How scan is able to identify what is the load on the server, how many users are connected on the server, what transaction they're doing? How my scan is aware of that? How many IPs the scan can have it? I just mentioned default is 3. Can I have a two IPs for scan, one IPs for scan, 5 IPs for scan, 8 IPs for scan, 10 IPs for scan? Yes, you can have it. There's no limitation for the scan IPs, but default is 3. Is a scan VIP or a physical IP or IP? Scan is always a VIP, virtual IP. We call this as a scan IP or the scan VIP. 98% we call it as a scan IP for the simplicity. But actually scan is a VIP. We should call it as scan VIP. Right? This is few of the questions, but when we talk actually our regular classes, we'll understand more in depth under each of these every concept. Right? And the other feature what we talked about is failover. Again in the failover, we talked yesterday, is failover support with the DML query, DDL query, TCL query, or select query? DML is like insert, update, delete. DDL is your create and drop, truncate. TCL is your grant and revoke. Right? And then the failover is only for select query. The user is connected to RAC node 1 and he's doing a select query. If that node 1 is down, let's say if the end user is connected here, client 1 connected here, connected to your node 1, this is went down. He's doing a select star from employee table. That employee table has a 2 million record. He got the output of 1 million record. The moment this fail over, the client will connect over here. And then the 1 million record already he got it. Let's continue from that 1 million record. Another 1 million record, you can pull it. Or let's discard that 1 million record, start it from the 0. Pull that entire 2 million record again. Those are the two types of failure. You want select query failure or the session failure. Let's failure only the session, re-execute that transaction once again, the select query. That's a select failure or the session failure. Select failure is like 1 million record is already extracted or came to client. Let's continue from where it has left out. Another 1 million record you can get it. That's a select failure. Session failure meaning 1 million record client already extracted. Let's discard that. Just fail over the session and start the query execution from the 0. Both the configuration will be able to do it. So this is called your transparent application failure, TAF. For the end user point of view, he will not be aware that there is a failure happened. It's all going to be transparent to that end user. Right? How we are able to provide this failure feature in RAC? Who is responsible for that? Who will be helping? We have something called VIPs in RAC cluster. VIPs will help in achieving this failover feature. And again, you should ask why VIP came into picture. Why VIP stands for virtual IP. Why VIP came into picture? To support this failover. And when this VIP is introduced, we'll discuss more in our actual classes. And this is what simple questions in most of the interview. What are the transactions are supported for a failover? Only select query transaction is supported for failover. Other than that, insert, update, delete, truncate, drop, those will not be supported for failover. Only select queries are supported for failover. Right? These are like in-depth details about the RAC features, what we discussed at high level in yesterday's session, why RAC, high availability and load balancing and failover. And in these three feature itself, we have so many sub-concept and that also needs in detail understanding. So now we talked about scan IPs, VIPs, and many other things. Let's quickly touch base on the networking part. Why this RAC networking will come into picture and what are the IPs we'll be dealing with. When it comes to rack networking, what are the IPs you may think of? How many IPs we need? We need it. How many IPs are needed in order to set up a two-node rack? What are the type of IPs are needed in order to set up a two-node rack? Let's say I want to set up a two-node rack, node 1 and node 2. The very first thing I need a physical IP for them. That I'll just put down here in this one notepad here. That I need a physical IP. We call it as the physical IP or the public IP. So let's say node1.localdomain.com or node1.wipro.com or node1.oracle.com, domain name and the host name, and node2.localdomain.com. And then the IP address 192.168.1.101, 192.168.1.102. Two IPs for the public IPs and physical IPs. Again, there might be a question here. What is a public IP? And then physical IP. What is physical IP? So those are like again commonly asked interview questions. The public IP, the name itself suggests, which is outside of your domain or outside of your network, where publicly you should be able to access that one. Physical IP, the moment you say physical IP is IP which is assigned to an interface. You have a ETH0, ETH1, and ETH3, 4. So the IP assigned for that interface is your physical IP. So that is the one set of IP what you need it. If it's a 3-node, you need a 3 IPs. If it's a 4-node rack cluster, you need a 4 IPs. That's a public IP. And the second set of IP what we need? A private IP. Again, private IP also a physical IP. Again, physical IP meaning IP assigned to interface. Private IP. So we just naming convention node 1 hyphen private PRIV priv. Node 1 hyphen private localdomain.com. Node 2 hyphen private localdomain.com. And again, what is a private IP? The name itself suggests private, which within your network. The IP, the network which is our IP, which is accessible within your network or within your domain. So if you look at here, this is a different subnet together. So your public IP, which is of 1 dot and 101, this is the 2.101. This IP is totally in a different subnet, a different network. And then other set of IPs, what we need? VIPs or the node VIPs. Node 1 hyphen VIP localdomain.com. VIPs. Node 2 hyphen VIP localdomain.com. So again, the VIP is same in your public IP network 1.101, 1.103, 1.102, 1.104. So two IPs are needed for two node rack setup. So VIP is other set of IP is what we need. In a simple definition, we need a public IP. How many nodes? You need those many public IPs. Private IP, how many rack cluster nodes? You need those many private IPs. VIPs again, how many rack cluster nodes? Those many VIPs you need it. And then finally, we have one more IP called scan IP. We call it as scan VIP. That's actual name is scan VIP, but some people with a short name they will call it as a scan IP. So again, what is scan VIP or scan IP? So scan VIP is nothing but physical, and what is VIP here? The VIP, what is VIP IP? It's a virtual IP, the IP assigned to a host where that does not have any interface. That's your VIP. The node VIPs and scan VIPs both are one and same. Those are virtual IPs. The moment I say virtual IPs, those IPs will not be assigned to any interface. They will be just tagged or pegging on existing interface. And then this set of scan VIPs default will be having a 3 IPs. I just mentioned here, right? The default scan is made up of 3 IPs or the 3 VIPs. So you can have 4, 5, 6. Just go with the standard 3 IPs. So those are your number of IPs what we need. To answer to this question, how many IPs are needed in order to set up 2 node rack? So you need a 2 public IP, right? 1.101, 1.102. And then you need a private IP, 2, 2.101, 2.102. Just say VIP. You need 1.103, 1.104. 2 VIPs and then followed by scan. Scan considering default as a 3. So those are your total number of IPs what you need. So that equation remains same if you go with how many IPs are needed in order to set up a 3 node rack. Public IPs just increase by 1. Private IP just increase by 1. VIP just increase by 1. Scan remains same, it is 3. 3 plus 3 plus 3 plus 3, total 12. And again same equation goes in order to set up your 4 node rack. So 4 public IPs, 4 private IPs, and 4 VIPs. Again, scan remains same 3. 4 plus 4 plus 3. That's your IP requirement for 4 node rack setup. That's why the underlying question is why these many IPs? Why it's so complex? Why public IPs or physical IPs needed? Why VIPs are needed? Why scan IPs are needed for rack setup? Why so much of complication? Again, we'll discuss in further what are these IPs and why we need these many IPs in our regular classes in more in-depth understanding. Right, this has become so complex that rack setup is totally, too complicated in terms of IPs requirement and others. So you need to work with your network admin and define all these IPs in DNS. So in simple definition, prior to 10G, only the public IPs or the physical IPs. There's no concept of VIP or there's no concept of scan IPs. Only physical IPs. Prior to 10G, if you are setting up of rack cluster, you just need this public IPs. That's it. If it's a 2 node rack setup, 2 public IPs. And if it's a 5 node or 10 node rack cluster, it's just 10 IPs are needed. That's it. And prior to 10G, what was the challenging? Failover was challenging. Failover was not supported. Load balancing was challenging. Load balancing was not proper. And whenever you are adding a node and deleting a node, it's a challenging for the end user. So in 10G, what they did, what Oracle has done, they introduced this VIP. Along with this public IP, the VIP came into picture. Now it become 2 set of IPs in 10G onwards. And with the help of these VIPs, we are able to handle this failover. The failover we are able to achieve. we are able to achieve this failover feature with help of these VIPs in 10G. Again, load balancing was challenging. Node addition or node deletion is always challenging for the end user. Whenever any extra node, it's a 2 node rack cluster, you make it as a 3 node or 4 node. Or currently it's a 8 node rack cluster, you remove that 2 of the node, make it 6 node rack cluster. The application team or end user has to reconfigure the TNS and application configuration. Right? To overcome that, in 11G, Oracle has introduced this scan IP or the scan VIP. Now we end up with public IPs, VIPs, and scan IPs. Why we are having these many IPs? These many IPs are evolved over a period of time. 9i, 10G, 11G, the IPs are keep adding, and that become your total IP requirement for your rack setup. And with the help of this scan, we are able to achieve this all the features. Failover we achieved by VIP, load balancing, we are able to achieve this one using a scan VIP, and node addition and node deletion we are able to achieve using scan VIP. That is the evolution of IP requirement and how we are able to achieve this high availability load balancing and the client. Right. And then again, other questions what we talked. Why 3 IPs or multiple IPs for scan? For the client side connection high availability and server side load balancing and all other stories. So that's a requirement why we have multiple IPs for scan. And the other questions you might have think of or you can get it in the interview. What is physical IP or public IP? The IP assigned to interface is called a physical IP. What is VIP? The IP does not have any interface. That's your VIP. That be ETH:1, ETH1:1, ENPS:0:2. It will be just tagging or pegging with this colon. And then what is scan or the scan VIP? IP do not have that. Again, the scan IP or the scan VIP is just a normal VIP. IP does not have any interface. What is private IP? Right? This private IP is same as your physical IP. And then the IP is assigned to a interface. But this will be a different subnet. So again, you might think of what is public IP. Public IP may be a physical IP or maybe a VIP. IP accessible outside of domain. And again here, what is private IP? Nothing but it's a physical IP which is different than your physical IP or different than your the public domain. Right, those are your different questions you may expect in the interview. And again, I repeatedly told this one, is a scan VIP or a physical IP? Scan is a VIP, the virtual IP, similar to that node VIP. So we mentioned here, private IP is nothing but a physical IP but in the different subnet than your public IP. That if you take a look here, your public IP is 1.101, your private IP is 2.101. Why it is in different domain, different network, sorry. The end user will connect in this particular one dot network, but the private internal communication will go under this two dot different network. There is a question why private IP is in a different network. Why can't this private IP in the same network of that physical IP? Right? If I draw the diagram for rack, give me 1 second. Give me 1 minute, guys. I'll be back in a minute. All right. Sorry for that, guys. Okay, so what I was talking, why this private IP is in the different network than the, you know, whatever the public IP we had it. Let's think of here, this is your scan, and then client will connect to scan. From scan, they will connect to the database instance 1 or database instance 2, which is running under this Linux server 1 and Linux server 2. Let's think of now this private IP is for internal communication between this server 1 and server 2. We're able to communicate. And also we have this database which is stored under this shared storage here. Your database will be here, the physical file. And then these disks are added to these VMs. The client 1 connected to instance 1 he will connect to database and he will get that select star from employee where employee ID equal to 1. The data will come over here, employee ID 1, and then the data will be given to that client. Let's say client 2 connect to scan, the connection will go to your instance, database instance 2. And the client 2 also looking for the same select star from employee where employee ID equal to 1. In that case, that select query will not go to that disk to get that employee ID 1 and then give it back to that end user. No, it's not going to go like that. Because the moment it go to disk, the reading from the disk is always slow performance, costlier. So rather than what happens, this instance 2 will ask this instance on boss, do you have that client employee ID 1 information? And then this instance will say, yes, I have it, take it. This employee ID 1 information will be transferred from this instance 1 to instance 2. And then that details will be given to that end user. So this is called cache fusion. So again, this is one of the common entry questions. Cache fusion. What's a cache fusion? Transferring blocks from one database instance to one database instance buffer cache, another instance. Right, that is your meaning of cache fusion. And if you look at here, cache fusion, we have transferred the block from Linux server 1 to Linux server 1. For that, we're using this private network. Other than this scan or the end user network is a public network where it will be used for only that end user communication. The data transfer between your database server or your RAC database to that end user. The data will flow from the end user to database in the public network, but the data transfer or the movement between your RAC cluster node is a private network. So if you have the private network and this public network in the same IP range, the end user may face that network throttling, network slowness. So we don't want to go that network issues, and because of that we segregated. For the end user, it should be a public network, and the private communication should have a different network so that both the network are segregated to get a better throughput. So we use this private IP for cluster communication, and that private IP is more oftenly used in the cluster for this block transfer communication. Let's say how this both the nodes are able to communicate each other. This node 1 will say, boss, are you still alive? Are you still part of the cluster? Node 1 will say, respond back, yes, I'm still part of the cluster, I'm alive. And at the same time, node 2 will ping node 1, boss, are you still part of the cluster? Are you still alive? Node 1 will respond back, yes, I'm still alive. The node to node communication will happen in this private network. And the data transfer between node 1 to node 2 or node 2 to node 1 happens in this private network. Right, the communication is called heartbeat, node to node communication. And then at the same time, we have something called OAT disk on the storage. The node 1 will access that OAT disk, node 2 will access that OAT disk. That's a disk heartbeat. The disk heartbeat, node to voting disk, whatever the voting disk, the disks available in the shared storage, or keep reading and accessing by all the cluster. If it's a 8 node rack cluster, all the 8 nodes will be keep accessing that voting disk. Right, so again that communication happens through this private network. And then this cache fusion, I just mentioned about this cache fusion, right? Cache fusion activity, the data transfer from one instance to another instance, data block. And all this other cluster communication. will all happen through this private network. So your private network is heavily used. And if you have a weak private network, then your cluster node will crash. Your cluster services or will crash. Right? Because of that, your private network or private IP should be in a different subnet together, a different network together than your public network. And also, we just mentioned how important this private network is. And Oracle came up with HAIP. High redundant IP. Meaning, rather than having one single IP for this private network, make it as a HA, high availability. What that meaning? Let's say same rack diagram. So Oracle will suggest, okay, boss, have it your interface 1 and have it interface 2. Combine these together and have it again interface 1 here, have it your interface 2 here, and then combine it and then start communicating with this private network. These are both are private interface. Two interface act as a one single IP, and one will be like active and other one will be passive. One will be active and other will be passive. Because your private network is so important, so heavily used, go with the two interfaces for the private network. One will act as a private, one will act as active, and one will act as a passive. In case of this interface goes, and automatically this passive interface become active, and communication will happen with this interface. And that's a new concept what came in 11G, the high redundant IP, HIP. Instead of having one interface for the private network, have multiple interface and combine them, make them for the sustained network. Right? And then that's the answer, like the physical IP, that's the public IP, and the VIP scan IP, or for the client connection, the data transfer from the database to end user. So those all will be in the same network. Public IPs, VIPs, and scan IPs for all are needed for your client communication or data transfer to that client. They all should be in the same network. If you take a look here, this IP 1 dot series, the public IP 1 dot series, and VIP 1 dot series. Your scan IP 1 dot series. All are in same network. Right? Those are your, in a simple definition, how this the IPs are evolved and what are the importance of IPs which constantly came in. Right, hope that's clear, or I'll take a pause here for a minute if anyone has any questions so far, or is all good so far. Any questions so far so good? Right. Let's move on then if no questions. Now, okay, now let's little bit talk on how this installation we used to do. So in what happens in prior to 10G? Prior to 10G, there are two separate softwares, or let's say three separate software. Clusterware software, ASM software, and database software. What we used to do prior to 10G, node 1, node 2. First, install cluster software. Download this cluster software from Oracle site and install it. Let's say use your own cluster. Use your own cluster. Both the node will act as a cluster now. Right? This will help, which will help node 1 and node 2 communicate and make two node cluster, this cluster software. And second, install ASM software. Download your ASM software from Oracle site and install it, like U01 ASM, U01 ASM. And this ASM software used to provide us the ASM storage and ASM instance and other stuff. And finally, install DB software. Download the database software and install it, U01. Right? U01 DB home 1. So with help of this database, home, we can create a RAC database. That's how we used to install 3 separate software. And post 10G, Oracle has came up with this grid concept, grid software. What Oracle has done, Oracle has combined that cluster software and ASM software together, bundled into one single software called grid. And now we have only 2 software, 10G, 11G, and your 12C, 18C, 19C, whatever it is, it's only 2 software, grid software and database software. So now the installation will be like, install grid software, download that grid software from Oracle site and install it, like U01 grid. I'm just giving a dummy names here, like node 2, U01 grid, which will help us in node 1 and node 2 communication and make 2 node cluster, and also it will get install your ASM and provide your ASM storage in one shot, single software. And followed by your database. So download and install your database software. U01 DB Home 1, U01 DB Home 2, where we can create our databases on top of this DB Home. Right, since in 11G, in 10G onwards, the grid is a combination of cluster home and SM home. So many people will call it as a many naming convention like this. Grid software or cluster software or ASM software, one and same. You may call it as a grid software or cluster software or ASM software. So with the help of this grid software or cluster software, ASM software, we install that grid home or ASM home or cluster home. All are referring to one and same. Use your own grid. So same terminology, your Oracle software, database software, DB software, all are like one and same here. With help of that Oracle software, we install Oracle Home, DB Home, or Database Home. You can call it as whatever you want. Oracle Home, DB Home, or Database Home. It's one and same. Use your own DB Home one. Right, and then let's say now the installation part. The grid infrastructure, we call it the grid infrastructure, GI, ASM, or the clusterware installation. Both are referring to, all are referring to same. Download this 19C grid software on node 1. This rack node 1, you can download it. Unzip that 19C grid software into that grid home wherever you want to install. From that grid home, run this grid setup.sh. Once you run this grid setup.sh, it's going to ask you all the IPs, public IPs, private IPs, scan IPs. Provide that all those details. And then that grid setup.sh will ask you to enter that node 1, node 2 details and all the node 1 and node 2 IPs. Once you pass all of them, you're going to copy that grid software from node 1 to node 2. Whatever this software we unzipped here, same software will be copied over to the second node. And then it will start your ASM instance 1 and ASM instance 2. And then do a cluster setup. And once that is done, You can go and then install your Oracle Home. Oracle Home, Database Home, or RAC Home, all are referring to same here. Download your 19C Oracle software on Node 1, only on Node 1, and unzip that 19C database software into that Oracle Home, the location where you want to install, only on Node 1, and run this run installer on that node. It will show all the RAC cluster nodes. Once the moment you run this one, it's going to show you, boss, it's a 2 node RAC cluster, it's a 4 node RAC cluster. Just select all of those nodes and then submit. You're going to set up that Oracle Home on node 1, and then you're going to copy that Oracle Home on the other RAC nodes, and then you're going to set up your 2 node RAC Oracle Home. Like it was your cluster software, cluster home, and then followed by now your Oracle Home is ready. Once your cluster setup is done, once your Oracle Home is done, now we'll proceed with the database creation. Database creation, what we do? Connect to node 1, go to that Oracle Home bin. From that Oracle Home bin location, we run this .dbca. It's going to ask you to enter the details, all your database name, SID, SGA, PGA, data file location, FR and all. Once you pass all these details and submit, and then it's going to create that database instance 1 here and database instance 2 here. And then your 2 node RAC database is ready. At looking at here, your cluster installation looks so simple. Your database home installation looks so simple, and your database creations look so simple. But when you really go with the actual implementation, there will be a lot of steps and a lot of implementation, pre-checks, post-checks, and during the installation, you have to monitor a lot of logs. All will come into picture. But at high level, if you take a look here, it will be straightforward 3-step activity: grid installation, Oracle installation, and database creation. Right? Hope that's clear. No questions. All looks good. Great. Let's
Malik,
quickly.
sorry, question.
Yes, go ahead.
If we have a 3 or 4 nodes cluster, so we install the grid in only node 1, and then the installer will copy it to all the cluster, to all
Right.
the other nodes.
Right. So we download that grid software on node 1 only, and we'll unzip that in node 1, and we run this grid setup.h. The moment you run it, it's gonna open the GUI mode. It's gonna ask you, enter all the physical IPs, private IPs, CAN IPs of your cluster node. If it's a 3 node rack cluster you want to set up, or 8 node rack cluster you want to set up, you need to enter that all the 8 node public IPs, VIPs, and the scan IPs. Once you enter it, you're gonna copy that software to your all the nodes. So again, there is some, again, just I mentioned that there are a lot of pre-checks you need to do. What is that pre-checks? You need to do SSH connectivity. Like, so you are installing your grid using a grid user or using a Oracle user. That Oracle user should have that SSH connectivity from node 1 to node 2 without any password. That's one of your pre-checks you have to do it. Let's say in my rack node here, if I get my lab, I have this lab 1 and I have this lab 2. 2 node rack setup, I have done it. If I check on my node 1, I have this plus ASM1 already installed. ORCL instance 1 is already running. If I check here on second node, my plus ASM2 is running and ORCL instance 2 is running. How I did a lab setup here? On this node 1, I ran that grid setup as a Oracle user, and prior to that, I already did a SSH setup. As a Oracle user, if I do SSH into my second node, it should not ask any password. So now from Oracle user from node 1, just do SSH Oracle lab 2. I'm able to connect to lab 2 without any password. If you don't have this SSH connectivity, then your installer will fail saying that unable to reach remote nodes.
Yeah.
Right? That is how your grid installation works, and the same way your Oracle installation also work the same manner. We'll download only on node 1. From there we're gonna run the run installer. Again, this run installer will launch the GUI screen, and you're gonna say, boss, I can see this is a 4 node rack cluster. You want to install on all the 4 nodes. You can select all the 4 nodes. Right? It can say the moment you run this run installer, it can launch the GUI screen. It says node 1, node 2, node 3, node 4. It's a 4 node rack cluster, and there will be checkbox. And
Yeah.
you have to mark that checkbox. Here we are not giving any IP address because the IP address and details will give it only at the cluster installation. And at the Oracle home installation, it automatically says, boss, it's a 4 node rack cluster. I can say, do you want to install this Oracle software in all the 4 nodes? You need to just do a checkbox, and then Oracle home will be installed on all the 4 nodes. Suppose you checkbox only node 1 and node 2, and your Oracle home will be installed on only this Oracle home here and Oracle home here. It's a 2 node Oracle home. If you checkbox on all the 4 nodes, and it will be 4 node Oracle home. You can do whatever you want it. Mix match. You want all the 4 node should have the Oracle home, or only 2 node you should have Oracle home. You can do that. So after that, you will go ahead and then create your database. You will go to that Oracle home, and you're going to run that DBCA. And let's say if you go with this Oracle home here and run the
Yeah.
DBCA, your database instance 1 will create here and database instance 2 will create here. And if you go to this Oracle home and run the DBCA, your test database instance 1, test database instance 2, and test database instance 3, and test database instance 4 will create here. So it's a 4 node RAC database here because Oracle home is 4 node. And here it's a 2 node RAC database here because Oracle home is 2 node. And likewise, some customer, what they will do, they will download the software, Oracle software on, after setting up of your grid, they will download Oracle software on 3rd node, and they will run the run installer, and they will do a checkbox only 3rd node and 4th node, and then they will get a new Oracle home 3, Oracle home 3 here. And then they will connect to this 3rd node and run the DBCA, and they will create a database called like UAT database 1. Here will be UAT database instance 3, UAT database instance 4. It's a 2 node rack database running only on 3 and 4 because Oracle home you set up only on 3 and 4. Right, so that's a heavy cluster. In case of when it comes to Exadata will be made up of 8 node, 16 node rack cluster. That time client will go with this kind of a segregation. Okay, last 4 node out of 8 node rack cluster node 7 and 8 for my development work. Like me install my development Oracle home on cluster node 7 and 8 and create a development database over there. Let me install Oracle software on cluster node 5 and 6 and create my test databases over there. Let me install my Oracle software on node 1, 2, 3, 4, where I need to run my production database, and then I'll install my production database over there. So you can do all this customization by installing your Oracle home across all the rack cluster nodes or only few rack cluster nodes, and you can segregate your load.
Is there any preference to have even or no odd numbers, or doesn't matter? We can have
Doesn't
2
matter.
or 3. Okay.
Yeah, it doesn't matter. You can go with a 2 node rack cluster. Ideally, the minimum node requirement for rack setup is 2. You cannot have a rack setup with 1 node. Minimum is needed 2 node. 2 node is must. With a 2 node client will initially go with a 2 node rack cluster, and over a period of time, as and when their business grows and more users are keep coming and accessing their application or transaction and databases, and if that 2 node rack is not sufficient, they will add one more node, make it 3 node rack cluster. And that's a node addition and node deletion. So you can do it online without impacting any database or end user connection. Make it 3 node. Once the 3 node is running, everything is fine. Again, over a period of time, your business is growing. 3 node is not enough. Again, add one more node, 4 node. So there's no dependencies. Minimum is 2 node, maximum you can go with a 3, 4, 5, 6. No dependency at all.
What about the RAC one node, which you mentioned yesterday?
Right.
Is it something same concept will be?
Yeah. So RAC one node is remains same here. So RAC database and RAC one node database.
Yeah.
So your Oracle home is remains same. It's a RAC Oracle home you're going to install. 4 node and 4 node Oracle home. Let's say here, 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 here. So you install your Oracle home, Oracle home,
Yeah.
Oracle home, Oracle home. It's a 4 node Oracle home installed. And from here, you're going to run the DBCA. While running the DBCA, it's going to ask you whether you want RAC database or whether you're going to ask RAC one node. The DBCA will ask what type of database you want it. If you go with the RAC database, your database instance 1, database instance 2, database instance 3, and database instance 4. Wherever you install Oracle Home, on all the nodes, your RAC database will get started. All the 4 RAC instance will get started. If you choose a RAC 1 node while DBCA running, and it will be like database development database underscore 1, development underscore 2, development underscore database instance 3, development underscore database instance 4. 4 database instance will be configured, but
Mhm.
only one will be up and running.
Okay.
And the moment this node goes down, or this development underscore 1 instance goes down, automatically any one of will auto start. So why this RAC 1 node? RAC licensing is costlier than this RAC 1 node. So I have a database called reporting database. Rather than running this reporting database as a RAC database, I'll create this reporting database because every day around 5 p.m. when my business closes, I need to run one report, which will run for 3 hours. Only for the reporting purpose, why should I pay more licensing cost and then create a RAC database? Instead of that, I'll go with a RAC one node database for this reporting database. And then I will always keep that dev underscore 4 instance up and running. And I'll always run the reporting queries from that instance 4 so that other 3 node I will not interfere. Let's production database up and running, and I'll just configure only one. So that is one purpose, like kind of a reporting or query database. I can go with this RAC one node. Even though it's kind of a RAC, underlining Oracle home is a RAC Oracle home, and the database is configured as a RAC database, but only one instance will be up and running.
So for RAC one node, we still need to pay for the license for the RAC, or it would be considered as
Yeah,
one.
lesser licensing cost. That's one of the advantages why people will go with RAC one node.
Okay. So in this case, considered as if it is standard database without RAC,
Yeah,
or
standalone
still?
database without RAC with the high availability is available. As I mentioned, that node goes
Oh, okay.
down, instance goes down, automatically it will start it on the other node.
Okay. And it would be much cheaper than the one with
Yeah.
multi. Okay. Okay.
Yeah. Compared to RAC versus RAC one node, RAC one node has a lesser license than the RAC.
Is it this is the only reason for having RAC one node, or there is another reason for that?
Another reason I
For
mentioned, right? There's a less critical database. I'll run it as a RAC one node and I'll move it to
yeah.
the last node where you're going to use that resource only from that node. So other resource you
Right.
can leave it for production workload. If you just make it as a RAC database, unnecessarily instance will be up and running and consume a lot of resource.
Yeah.
So now quickly, if I go here for this oracleworld, there's a command srctl config database -d oracl. So that the moment you run this command, it will tell you what type of a database it is. The type it says RAC, it meaning it's a multiple nodes. And if it says RAC underscore one node, RAC one node, and you can see here instance name, the standard instance name RAC underscore one, like oracl underscore one, oracl underscore two, configured on all the RAC nodes. This is one way to verify whether the database is RAC or standalone or RAC
Okay.
one node. All right.
Thank you.
Right. Then couple of other things. For when it comes to standalone, so what we're going to do? We're going to do database instance plus database. We're going to manage database instance and database, which is data files, for one single instance. Again, the moment I say instance, which will be a combination of your memory and background process, and the moment I say database, it's all about your data files. We manage using SRVCTL or SQL plus. Right? It's just one single database and database instance maintenance or management. In case of, right, we just do manage one single database instance and one single database. The moment I say instance, it's a memory and background process. The moment I say database, it's a data files. I can manage using SRCTL utility or the SQL plus command line. Right, we use this SRCTL config, status, stop, start, instance level, database level, and all. But when it comes to RAC, manage database instances, DevDB1, DevDB2. We need to manage these instances on multiple servers. The moment I say instances, memory and background process. And the moment I say database, it's just a data file. Again, same thing, I can use SRCTL utilities or the SQL plus command line. Right, again, I can go with the management of the database at my cluster level. Like my database is ORCL1, ORCL2, ORCL. I'll just go with I just this config. Now if I do status, I no need to log into all the cluster nodes. Just do one cluster node. I'll log into this one server. I can get the status from all the nodes. ORCL underscore ORCL1, ORCL2 running successfully, running fine from node 1 and node 2. Right, I can go with entire database level. Like if I do SRCTL stop database, it's gonna stop this ORCL instance 1 on node 1. You're gonna stop this ORCL instance 2 from node 2. I no need to connect to second node. You're gonna do it everything from one node only. And also I can go with instance wise management running this command. SRCTL status instance. What's the status of my DevDB instance 1? What's the status of my DevDB instance 2? If I go with this one, one, two, one, one, two, one, two. So if I check this status from any node, any cluster node. So being from the node 1, I'm able to get that ORCL1 instance status. Again, being from the node 1, I'm able to get my ORCL instance 2 status. I can do shutdown the instance 2 from the server 1. The administration will become very simple here in case of RAC. You can just connect to any one cluster node and maintain and manage your database. That's your RAC administration, RAC database administration, Rail application cluster database. And then what is extra here? Your cluster management. The cluster management is an extra major activity in case of RAC. We use something called CRSTL utility, and then we're going to manage and maintain. There will be a lot of cluster resource, lot of cluster daemons, and there's a cluster startup sequence where we need to maintain and manage. So simple definition here, if I take a look from the node 1 plus 1, CRSCTL stat resource hyphen T hyphen init. From this node 1, Oracle Lab 1, we have so many cluster resource here. And if I go to second node, .inv plus ASM2 CRSCTL stat resource hyphen T hyphen init. So again, there are so many cluster resource on second node. We need to maintain this all resource healthy state on node 1, node 2. If it's a 4 node rack cluster, you need to maintain this cluster resource in healthy state across all the 4 nodes. And whatever the cluster resource we are seeing, all those will be represented as a OS level daemons. If I do ps-ef grep d.bin. So whatever we are seeing here, CTSSD, CSSD, CRSD, CSSD monitor, UMD, JIPCD, GPNPD, MDNSD storage, all these are represented as your OS process or OS daemon, OHSD, ORA agent, UMD, MDNSD, GPNPD, GIPCD, CSSD monitor, CSSD agent, CSSD, CRSD. So all are your OS level daemon. Same thing from your node 1 as well. If I go to node 1 here, right? OS process, OS daemons, and the cluster resource. So we need to maintain all of this. So I can go for this individual service. I can run this one single command to check all the cluster resource, or I can go with the individual status check. So I can go with the CRSCTL check CRS, CRSCTL check HAS, CRSCTL check. So I can go with the individual service check or the entire cluster level check. So there are a lot of commands what we can deal with. So now I want to do any maintenance on this node 1. I need to shut down all those cluster services, databases, instances, and ASM, everything. Right, so I can just give these simple commands here. So I can do cluster service check one by one, or I can do stop and start your cluster resource. In a simple definition here, when it comes to RAC cluster administration, it has a hierarchy. So each RAC node has HAS, that's the foundation, Oracle High Availability Service. On top of that HAS, you have your CRS, Cluster Ready Service. On top of the CRS, you have your ASM. On top of this ASM, you have your database instance. So if you're doing any maintenance on this RAC node 1, you have to shut down your database instance, shut down your ASM instance, shut down your CRS, and shut down your HAS. Then you can do any maintenance on this node 1 or 2. If you want to do any maintenance on this node 2, shut down your database instance, shut down your ASM instance, shut down your CRS, and shut down your HAS, and then do maintenance. So you have to like shut down your database, ASM, CRS one by one, or directly go and then shut down your HAS. The moment you shut down your HAS, CRS will go down, ASM will go down, and your database instance will go down. Let's say take a look here. PS-EF grep smon. You have a database instance, you have ASM instance, and CRS CTL. stat resource -t -init, and all other stat resource -t -init. So all your CRS and all the cluster resource. The moment I shut down this HAS, CRSETL stop HAS. That's your fundamental foundation. Your entire rack cluster will start on this HAS, followed by CRS and ASM and other cluster service. The moment I stop HAS, your entire service will go down on this node. So, but is it a best practice to do this stop HAS? The moment you do stop HAS, you're going to do shutdown abort. Your database instance will be always shutdown abort. So best practice always make sure that you stop your database instance first. When the database instance is down, how you can start the database instance or stop the database instance? SLCTL stop instance ORCL1. You're doing a maintenance on node 1, touch only node 1. Once you shut down your database or the node for maintenance, all the end user connections will go to your second node. There's no downtime in case of rack for any maintenance or any patching or anything you want to do it, because you're touching only one node at a time. Other node will be up and running.
Like, and where are the data files located on node 1 or node 2, or doesn't matter?
Your database is a shared one, right? Like here.
Yeah, the
Your database
files shared on shared. Okay,
right?
on
You are
shared
talking about
for
only on the server level, any maintenance. Right? Any client will be connected to your second instance or third instance, and they'll be accessing the same data files which are under shared location.
okay. So the best practice is to have them on shared folder, something
It,
like
yeah, it has to be
SAN or
yeah, so that is part of your installation, you'll understand more. So we have
okay.
raw disk or we have virtual disk, block devices, and ASM filter driver. Many method to have the shared disk, and then based upon what kind of a disk you have it, block devices or the raw devices or the physical devices or the virtual devices, it has to be shared. If it's a 4 node rack cluster, the same disk will be added to that all the 4 nodes. That's if it's a physical disk, then you need to have the common location and then map those IP addresses to all the nodes. And if it's coming from any storage vendor, then you need to have that storage path on all the nodes. All right. So that is your right now. If I take a look here, now everything is down. Gap SMON, no ASM, no database, no cluster services, right? Fail to connect your high availability service because underlining HAS you stopped it. If I start my HAS, everything will comes back online. All right, so that is a simple manage, simple administration tricks what I just mentioned. If it's a standalone, we'll just maintain one instance, one database using SQL or SQL plus command line. That's it. One server, because it will be running in one server, one instance, one database. And in case of rack, it's a multiple instances, multiple servers, and database will be shared, the data files, and you have to maintain and manage which instance you are setting down, where you are setting, which node you are setting down. And on top of this rack, multiple instance management, underlying your database is single database, the data files. That's one different. Multiple instance will come into picture in case of rack. And what is extra? This cluster management. All the cluster demand resource, you should make sure that all of them are up and running. If any one of the cluster resource is down or not running, then your node will go down. That node will be evicted from your cluster. That's your major activity where we do cluster level maintenance or the management. All right. So with that, I'm going to stop it for today here, provided if anyone has any questions so far. So far in yesterday's sessions, what we covered or whatever the course curriculum content or today, whatever technical things what we discussed. Right. Today, I think much more on the networking and the architecture part. There are much more to cover in our regular classes. So I will wait for the regular class to begin, and then we'll have one more round of discussion around all this and then go in depth of physically we'll go and then see all these files, all these IP addresses, how they look on that my setup, and we'll do the same setup on your laptop. And then once you do this setup by assigning your own IP, defining IPs by your own and creating this cluster by your own, then you will get to know more in-depth knowledge on this each and every concept what I just covered. All right. So any more last questions, guys, before I stop it for today? Any questions, queries around the course or the course curriculum content or the timing? All right. I'll take it as a no. If no questions, then we can wrap it for today. Look forward in our regular classes, which is starting on 20th, 20th or 23rd. I think 23rd. Right, yeah, we'll go forward. Once the regular class starts, we'll have more details on that. Until then, take care, guys. Thank
Thank
you
you.
all.
Thank you, Malikazu.
Thank you all. Bye.
Yeah.